What's up, Precal? So today we talked about arithmetic sequence, and we went over a few examples. Again, arithmetic sequence meaning you're just adding one to the next number. Arithmetic sequence would be like 1, 4, 7, 10, because you keep adding by 3 each time. And by the way, that 3 we call our common difference. The amount that you're adding each time, we call that our common difference, or in this case, D. So the first example that we did said find the sixth term and explicit formula using U sub 1 and D. Okay, U sub 1 means our first term, D is our common difference. Well, in order to find the sixth term, you need to know the formula for finding any term, and that would be U sub n is equal to U sub 1 plus n minus 1 times D. Okay? U sub n means whatever term you're looking for. U sub 1 means your first term. N is the amount of terms that we're dealing with. And D is our common difference. So if we're trying to find the sixth term, we're given the info that our first term is 6. The common difference is 3. Well, we know since we're trying to find the sixth term that n, in this case, is equal to 6 as well. Okay? So since it's a formula, just plug straight into the formula. Don't try to change a formula. That defeats the purpose of it being a formula. So, we're looking for the sixth term, U sub 6. Okay? The sixth term is equal to our first term plus n, which is 6 minus 1, times our difference, which is 3. That's our common difference. So therefore, U sub 6 is equal to 6 plus, this becomes 5 times 3 is 15. Therefore, our sixth term is going to be 21. Basic, simple, that's all you got to do. If you're trying to find your sixth term, when you know U sub 1 and you know D, it becomes very simple. So, you get 21. Alright? Now, it also says find the explicit formula. So the reason why we find the explicit formula is so that we can plug in, if we wanted to find the 100th term, is there some type of, the explicit formula helps us to answer that really quickly. So the way we do that is do the same exact problem, it's just don't plug in a number for n. Let's leave n the way it is, okay? So we're going to find U sub n if we know our first term is 6 and our common difference is 3. So we're going to plug n right there. So now we get 6. What we're going to do is distribute the 3. So plus 3n minus 3. So therefore U sub n is equal to 3n, and then 6 minus 3 is 3. This would be our explicit formula. Again, this is useful because if I said find the 100th term, all I have to do is plug that in for n. I know my 100th term is going to be 303. So all I got to do is plug it in for n. Okay? So that's our first set of examples. Find the sixth term and explicit formula if you're given those bits of information. So good luck with that. And on to example 2. Okay, so for example 2, this is what we call sigma notation. Okay? We're trying to find the sum. This is sigma notation. This will help us find the sum. Now the formula to find sum, by the way, S sub n, S standing for sum, common sense, right, is n over 2 times, we're using U sub 1 plus U sub n. Basically all that means is your first term plus your last term. Okay? Now if we're given this information, n is the number of terms we're dealing with. So you just have to figure out how many numbers are there from 1 to 7. So obviously, in this case, n is going to equal 7. Okay, from 1 to 7. Now to find your first term, all you have to do is plug in the bottom into this explicit formula. So when you plug 1 into n, you get 4 times 1, which is just 4. And to find your last term, you plug the top in. 7 times 4 is going to give us 28. So from here, to find our sum, we just plug in exactly into that formula. We have 7 over 2 times 4 plus 28. Therefore, you have 7 over 2 times 32, which that reduces. This becomes 16. So S sub n is equal to 70 plus 42, 112. That would be our final answer if we're trying to find the sum. Okay, so again, very easy. Establish what is your first term, what's your last term, how many terms are there. Once you know those 3 bits of information, you just plug it into the formula, and it's piece cake from there. Alright, that's example 2. So, for example 3, we still want to find the sum, or in the book it'll say find the partial sum. Okay? So in this problem, you know, you think you'd be able to use the sum formula like this, but the problem is we don't know what our last term is. So there's actually a second formula you can use to find the sum. It's S sub n is equal to n over 2, then bracket, 2u sub 1 plus n minus 1 times d. Okay? Now, in this problem, k is going to take the place of n. It means the same thing. So, we can go ahead and plug exactly into our formula. So, S sub n is equal to n over 2, in this case, k. So, 5 over 2. Then our brackets, we have 2 times our first term, which is 3, plus n minus 1. N again is k, so 5 minus 1 times d, which in this case is 4. And then from here you just do regular math, PEMDAS, right? So we have 5 over 2. This becomes 6 plus 5 minus 1 is 4 times 4 is 16. So you have 5 over 2 times 22, which the 2 and the 22 reduce. This becomes a 1. This becomes 11. So 5 times 11 is 55. And that will give you S sub n. It's equal to 55. Alright? So again, this is the formula you use if you don't know the last term. Okay, we know the first term, we know the difference, we know the number of terms. We just don't know the last term, so we can't use that formula. We have to use this one. Okay? So good luck with those. Example 4, okay, we are asked to find u sub 5 and the explicit formula for u sub n using the information given, which will be u sub 7 and d. So we have to use these 2 bits of information to find u sub 5 and the explicit formula. Okay. Now, we're not asked to find the sum, so we know we're going to use u sub n is equal to u sub 1 plus n minus 1 d. Okay? Now the problem is we don't know what u sub 1 is. But what we can do is just, in our minds, make u sub 5, put it in that place. So now I can say u sub 7, our last term, is equal to our first term given, plus n minus 1 d. The thing about this n is now I have to count how many terms are there from 5 to 7. So we're actually not going from 1 to 7, we're going from 5 to 7. So 5, 6, 7, n is actually 3 in this problem. If this were u sub 9, it would be 5, 6, 7, 8, 9. Okay. Now let's plug in some values. We know 9 is u sub 7. We don't know u sub 5. We know we have 3 minus 1 times d. In this case, d is 3. Okay, so let's just do regular math here and we'll be good. 9 equals u sub 5 plus 3 minus 1 is 2 times 3, which is 6. Subtract the 6. U sub 5 has to be equal to 3. Okay? So which makes sense. If your fifth term is 3 and you add 3 to that, you get 6. Add 3 to that, you get 9 for your 7th term. So, again, this plays a role of u sub 1. This plays the role of your last term. And figure out how far is it from your first term to your last term. In this instance, it is 3. 5, 6, 7. Okay? N would be 3. Now, it also asks us to find the explicit rule. So again, we're going to do the same thing, just don't plug in. Sorry. We know that now u sub 5, okay, is equal to 3. So now what we can do, okay, is plug in. So if we had u sub 7 is equal to u sub 5 plus n minus 1d, okay, let's plug some of those values in. So sorry. We can use this information now to find our first term, okay? Now what we're going to do is say u sub 5 is equal to u sub 1 plus n minus 1d. But how far is it from 1 to 5? We know that n has to be 5. We're trying to find our first term. We need to find our first term in order to create an explicit formula, okay? So now 3 is equal to u sub 1 plus, and we know d is equal to 3. 5 minus 1 is 4 times 3 is 12. So we move the 12 over. We know u sub 1 is equal to negative 9. Okay? U sub 1 is equal to negative 9. So that's going to help us make our explicit formula. So our explicit formula says, leave this side alone, u sub n. Okay? Now we know that this is, we know what u sub 1 is. We know it's negative 9 plus n minus 1d, which is 3. To find the explicit formula, do not plug in for n. Okay? But we needed our first term. That's why we found our first term, because we need our first term there. Okay? So now we have u sub n is equal to negative 9 plus 3n minus 3. So our final answer is u sub n is equal to 3n minus 12. Okay? And that is how we find our explicit formula. Again, we found u sub 5. Now we use u sub 5 to find u sub 1. And once we have u sub 1, our first term, we plug it in so we can find our explicit formula. I know that seemed a little confusing right there, but hopefully you followed along. If you didn't, watch the video over. Maybe it'll make sense the second time around. So good luck, and only one more example after this. So you're doing great. Keep watching. All right. So for our last example, it wants us to find the sum of the odd integers from 1 to 50. Again, this doesn't have to be that hard. We just have to figure out what variables we need. Again, to find sum, all we need is the number of terms. We need to know our first term and our last term. Okay? Well, let's think about this. Odd integers, there's 50 numbers. Half of them are odd, half of them are even. So therefore, the number of odd integers from 1 to 50 is going to be 25. Because again, half the numbers from 1 to 50 are even, half are odd. And we know our first term. What's your first odd integer? It's 1. What's your last odd integer that's less than 50? 49. Okay? So from here, we just do some math here. 25 over 2 times 50. Then this reduces to make 25. So we have 25 times 25, which is 625. So this would be your final answer for the sum of the odd integers from 1 to 50. If you were to add all those odd integers up, you get 625. Good luck with these problems with the arithmetic sequence. Hopefully this makes sense to you. And if not, ask me questions. I'm all for it. Ask away. I want to help you and want to see you guys succeed. So keep watching the video over if it helps, and good luck.